There's two types. The first type of exponential is growth. Which way do you write? Excuse me. Left to right. That's how you read graphs. So if you were like walking on this graph right here, left to right, you'd be going what? Good. So growth is going uphill. That's how you tell if it's a growth function. Growth exponential, excuse me. It's going uphill. Also, the way you can tell is your base, and I'll tell you what that is in a minute, is not a fraction. So your base has to be greater than 1. And I'll show you an example like numbers 1 through 3. Our base is what has the exponent. So this one is what? 2. So it'll be a growth function. This one's 1/4. See how it's a fraction? So it's going to be decay. This one, the base is what? 3. So it'll be a growth function. So 1 and 3 that we're graphing will look uphill. Number 2, since the base is a fraction, it'll be a exponential decay function, which means that if you were walking on this graph, you'd be going what? Downhill. That's what it looks like. But for each graph, and y'all are going to like this, because on the table you only need 3 points. And it's going to be the same 3 for each graph, and you can see that here. This is -1, 1 over b. B stands for what? B stands for what? What we just talked about. Base. Good. And then you'll have 1b and 0, 1 for each graph, whether it's decay or exponential, same points. -1, 1 over b, 1b, 0, 1. And you'll have to memorize those values, but we'll use them so much that you'll have to memorize. Alright, so making a table for number 1. Again, my x values come from here. And what are my x values that we see of all 3 points? And, yep, so let's list those in order. -1, 0, and 1. Those will always be your x values. But your y values depend on the base, and our base is what here? 2. So for -1, it's 1 over your base. So ours will be what? 1 over 2. Good. For 0, your y value will always be what? 1. Doesn't matter about your base. It'll always be 1. And y, oh, sorry, yes. Yeah. And that's because anything raised to the 0 power is always going to be what? 1. That's how you remember that. Sorry. And then the 1 is going to be 1 base, and our base is what? Come on, guys. Y'all know what the base is. I just have to start calling on people. Makes me sad. Alright, now we got our 3 points. Just got to graph them. Go ahead and graph them on your own. Sorry, the graph's tiny. And then exponential functions never end on either side, so this is going to never stop on this side. Same thing here. But notice how your these values are getting closer and closer together. So that's what your graph needs to reflect on this side. It's going to bottom out eventually. Last thing is the domain and range. Domain's talking about which values? X. Good. Okay, so Abigail Lund, how far left is this graph going to go? So, good. Simon, how far right is this graph going to go? Perfect. Do you think that'll change? Nope. And you can see like here that it'll always go from -infinity to +infinity because it never ends on either side. So that'll always be the domain. Now the range is dealing with what values? Yes. So what does it look like the lowest point on this graph is, or where it's approaching? 0. Good. It looks like it's approaching 0, this y value, but if it's approaching it, does it ever reach it? Nope. So what do we need right here? No, it's 0, but what we need here? That's if it reaches 0. It's not going to reach 0. It's just approaching it. And where is it going as far as like how high does it go? Very good. Oops. Now do you think the range is going to change? Yes. And you'll see why in a minute. And this is going uphill. That's how you know it's correct. You could also, if you wanted to, use your calculator table values on this if you wanted to. But if not, it's pretty easy to do it by hand. Any questions on that one? Alright, next one. What are my x values? Caleb. Good. Alright, here our base is 1/4, so for -1, when it's 1 over 1/4, that's going to give us what? 1 over 1/4. What'd you get, Nicole? Yes, that's correct. So shortcut to that, if it's a fraction, this -1 is always going to be the what from here? Denominator. That's pretty easy. Alright, so Hope was my value for 0. Alex was my value for 1. Perfect. And that came from here. 1 is going to be 1b. So 1 in your base. Let's graph it. Oops, that's not 1. It looks like a 0. Right here, it's always going to be 1b. So 1 and then your base is 1/4. It's always going to be 1b. So 1 and then your base is 2. Alright, make sure it goes on forever on both sides. This one's DK because it's going downhill plus the base is a fraction. Alright, Amy, what about the domain for this one? Domain. Oh, sorry, Amy. Yes, Sid, what about the range? 2. Perfect. Because you can see it's approaching this. The lowest point it's approaching is 0. Highest point would just be infinity. Questions about those? We'll do one more together. Still got to make a table. Still my x values are what? Good. And ignore these for a second. Just looking at our base for these values. Connor, what's going to be my first one?
1/3.
Good. Julie, what's going to be my next one for 0?
1.
Good. Evan, what's going to be my last one?
3.
Perfect. Okay. It's just a pattern. You pretty much just have to memorize these, but like I said, we're going to do them so much you'll have them. Now we'll worry about this 2 and this -2. Alright, the 2 is with what? The x. So it's going to be affecting our x values. What do you think we're going to do to them?
Subtract 2.
Good. Because x is a joker, so subtract 2. What do you think the -2 here on the outside is dealing with?
1.
So what should we do to them?
Subtract.
Good. What about the 3? Nope. Why don't we do anything with it? Yes, because we already did right here, right? We already used the 3 when we were finding these values. Does that make sense? So you only have to worry about these 2. So I'm going to mark that one out. Alright, so tell me, I'll have to rewrite my table because I don't have room. Tell me my new x values once I subtract 2 from these. Very good. And tell me my new y values. You can leave it as a decimal if you want. Good. That's fine that you rounded. It'll be the same when you graph it. What about -2? And last one? Good. Go ahead and graph your new table values. Oops. Alright, think about the domain and range for a second before we talk about it. Alright, Bryant, what would be our domain?
Negative infinity.
Very good. And Toby, what do you think our range will be? Perfect. You can see it's approaching -2, and sometimes it's hard to tell from your graph, right? Well, look at your y values. As it's going towards the center, it's approaching -2. But also, you can look at this, right? So shortcut, range is always going to be this number to infinity. That's all. This number, -2 to infinity. And that's all of chapter 7.1. Y'all feel good about that? Okay. Flip it. Now moving on to 7.2. So that was graphing exponential. This is solving exponential equations. What are we solving for in number 1? N, right? The letter we're solving for. But we need to get it out of the exponent. So to do this, we have to find a common base. Now, what are our bases here on each side? 4 and 64. What's the smallest? So let's focus on 4 first. Whatever's the smallest base, that's the one we don't want to change. We want to leave the smallest one alone. So we want to make these bases be the same. And again, we want to make it be 4 since it's the smallest. Okay, so we want to change this to 4 to something power. Can we raise 4 to a power to get 64? What power?
4.
Check it. 4 to the 4th. Check it. 4 cubed. Everybody agree it's 64? Good. So we can rewrite this instead of 64 as 4 cubed, because aren't they the same thing? And leave this one because it already had a base of 4. Now they have the same base, so what we can do here is cross out the 4's and set the exponents equal to one another. You can only do this when they have the same base. So the exponents would be 2n minus 1 equals 3, and now just solve by algebra. So how would I solve this one now? Add 1 and then divide by, which is good. Now these don't have extraneous solutions, but if you wanted to check this one, you just plug it back into the exponent by your calculator in your head or on paper. We'll just do this one together. When I plug 2 in, 2 times 2 is what? Minus 1. 4 cubed. Good. So you can kind of check it to yourself. Questions about that one? Alright, number 2. What's the smallest base? So this is the one we don't want to change. So could we change this to a 3? By raising it to the what power? Good, because 3 to the 3rd power is what? Good. But this one already has an exponent. So what do we do with it? Very good. Bring it down. We can multiply it. Cancel out our 3's. So I'll have 5x equals what? Very good. What should I move? So it'd be, so x equals 12. Perfect. Everybody good with those two? Try 3 on your own. You should get a fraction on this one, so don't think you're wrong if you got a fraction. Anybody want more time? Alright, what we get? 8/3. Very good. I need to go over it? Nope. Everybody's good? What was the common base? 7. Good. So that was the answer, 8/3. Alright, looking at number 4. What's the smallest number you see? The smallest base? Yes, actually this one's smaller, right? But I want you to ignore the 1. Which one's smaller? 4. Okay, ignore the 1 still. So this is what I want to leave the same. Can I change this to a 4? 4 to the what power? 3rd, right? So if it's 1 over this, it has to be to the what power? -3rd. Good. Let me show you. If I had 4 to the -3, to make it positive, I'd move it to the what? Bottom. And put a what on top? So I'd have 1 over what? Everybody see how these are the same? So if a fraction is involved, then that means that what's involved? Negative exponent. Good. Alright, so moving back down. Do we have to change the 4? No. We change this to 4 to the what power? Perfect. Then I can cancel these. I'd have 2x minus 5 equals -3. Then I should do what? So I get 2x equals, x equals, good. Questions about that? Alright. Last one we'll do together. What's the smallest base? So we don't want to change that if we don't have to. Can I raise 9 to a power to get 27? No. So let's look back at the smallest one. Can I change 9? Can you raise anything to a power to get 9? 3, right? So I want to change this to 3 squared, right? Bring down the other exponent. Can I change this to a base of 3? 3 what? Cubed. Good. So sometimes you have to change both of them if you can't raise the smallest one to that number. Does that make sense? Alright, so tell me what my exponents will be. On the left side we'll have plus on this side. Very good. Which did y'all move first? Okay, so we get negative 20x plus 10 equals -30. Then I'd have to do what? And get, so x equals? Very good. Questions? That's all of chapter 7-2. So y'all feel good about those chapters? What I'm going to do now, this is your homework, these 11 problems. And they're actually due tomorrow. So don't forget, these 11 problems due tomorrow. You could probably finish them in class after your checkpoint. So I'm going to pass out this checkpoint. Before that, does anybody have any questions about the chapters that we just did? Yes. You have a question about one on the front? Gotcha. I'll be there in a second. I'll show you because you kind of missed that first part. Any other questions? You can use your notes if you would like. Once you get done, raise your hand. I'll come check it. Again, if you didn't get something right, I'll just circle it so you can fix it on your own. After you finish this and you've gotten 100, start on your homework. And then if you finish both of them and I've seen it, you can pack up. Stop recording.